Hello guys, Winston here. Welcome to the second video of how to make a parametric gift box for just about anything. Don't expect this video to be nearly as entertaining as the first video. I'm just going to be here talking to my microphone, going through Fusion, showing you guys how you can make a parametric box of just about any size, and also walk you through the model and some of the features and how I designed this specific box. So let's open up an empty project. So I can show you how you can use parameters, how to set them up. The first place you'll want to go is the change parameters feature. If you don't see that, you can go to the modify dropdown, go to change parameters down here, hover over it, wait for the three dots to show up, click on that, and hit pin to toolbar. This is great for your most commonly used functions. And for me, parameters is definitely up there. Now, when you open this window, you have the option to add parameters. So hit the little plus button, and then you can make parameters called whatever you want. I don't think you can use spaces, but for a box, your most obvious choices are probably length. I'll say 2 inches. And let's add width. Let's call that 3 inches. And height. Enter expression, let's go 1 inch. We'll make a 1, 2, 3 block. Hit OK, and then I'm going to create a sketch in the XY plane. I like XY just because when you go into the manufacturing workspace, Z is already oriented with the natural direction of the spindle. So I'll do a center point rectangle. I personally like modeling from the origin. We'll go, normally you just type in numbers here, but here I'm going to go, I guess this will be width. You just start typing. As soon as the first couple letters comes in, it searches through your parameters and suggests values there. And then here, this will be length. I would recommend when you're designing parameters to not name them anything starting with IN or M if you can avoid it, just because if you're trying to type units, it'll still try and suggest parameters to you. For me, inches is a common one just because sometimes I design in metric, but I have stock or different features that are in inches. And as soon as I start typing, even if I start typing I now, it'll suggest width and height because it has the letter I in there. But if you have a feature or a parameter with IN in it and you're trying to type inches, it'll actually try and shove that parameter in there instead of the unit. So keep that in mind when you're naming your parameters, but for now, length is totally okay. Finish sketch. And then now when you are extruding, you can also drop in a parameter there. So height will go in, and that is a rectangular prism. And now if you want to hollow this out, if you want to put in a cavity here, you can go back to the parameter manager and just add a parameter. You can do the internal width and height or length of that cavity. I'm going to do something a little simpler. I'm just going to call this margin, and I'm going to say 0.2 inches. And then for the depth of this cavity, it is 11 p.m. I have not had a lot of sleep this week, so I can't really speak coherently. Let's go 0.75 inches. And so I will create another sketch on this face, and then I will double click on the edge to select that outer profile, hit O for offset, and note the direction of the offset. This is a negative offset, so we want to go negative margin. That gives us an inset contour, which we can then extrude to. Note the sign again, negative depth. And that is the beginnings of a box. Now, if you plan ahead and you know what kind of features you need to define ahead of time, you can put all of them in the table or just add more as you go along. That's basically how I designed the little parametric gift box here. All of these features are in the parameter manager. So I have the width of the lip, which is this little guy here, the ledge thickness, how inset that lip is, thickness, diameter of the magnets that I'm using, overall length, width, height. The box half height is sort of an assumption I made that I would be machining this from a just probably a 3/4 inch board. So ideally, the height of the base and the lid would be very similar, minus this little lip feature. So as long as the box half height plus the lip thickness is less than the total thickness of your stock, you're good to go. You could also make the top half and the bottom half asymmetrical. That's up to you. For me, it was easier just to design this with the box halves being as close as mirrored as possible. So let's walk through some of these sketches. So first thing I did, create a sketch, overall length and overall width. And then here, this radius is also predefined, called outer radius. I will extrude that out to a height of box half height. And then second sketch is the location of the magnet. The magnet diameter is a parameter. How inset that magnet pocket is could also be a parameter. Visually, I think using a ratio is perfectly adequate, and it saves you from having to make another parameter. Just keeps everything a little cleaner. The extrude function uses the magnet thickness, which is actually a couple thou thicker than the magnet actually is. It's a 16th inch magnet, but since it was probably manufactured in China, it's probably a 1.5 millimeter magnet. But you want this pocket to be a little deeper than your magnet actually is, so your magnet isn't flush with the top surface of your box. That means when you put the lid together with the base, there's actually a small gap between the magnets. And if you have a bubble of CA glue or something that you don't push the magnet in all the way, the magnet's not going to be proud of that surface, and the box halves will still be able to close seamlessly. Plus, the further away these magnets are, the weaker the attractive force is, so you can actually sort of tune the force it takes to pry the box halves apart. So I like to just go a couple thou deeper than the magnet actually is tall. You could go even more aggressive, but then you'll have a little bit more of a reveal of this sidewall above the magnet. I will just mirror this feature. I could have just drawn 2 magnet holes, but mirroring that extrude was just as easy, and I was lazy. I created a mirror plane here. This is how we're going to make the lid. I just start them off basically identically, and then I add a positive feature here, and I subtract that reciprocal feature over here. The next sketch is for that little lip that protrudes out. So here, this is defined, I guess this first contour is the ledge thickness minus nominal gap. So ledge thickness is how much of a ledge here you have before this proud feature starts. And then there's a nominal gap here that just pushes it in just a little bit more. Because if you didn't have that, the lip that comes out of this box would interfere basically with the negative feature in the lid. Let me just zoom ahead to show you that. So this feature, you want this face to not be coplanar with this face. You want them to have a little bit of a separation. Otherwise, you're going to have problems. So you can see the 2 faces are not coplanar. So that's what that nominal gap is. You can tune it depending on your CNC, your backlash, how much rebound you get from the wood as you machine it, and just tune that to get the desired fit. But let's scroll back to here-ish. Control 6 to switch back to shaded view. So I extruded this out. This is, again, another parameter, the lip height. Next sketch is for the, just the inset feature here. So that just basically matches this, and then I will remove a little extra material on top of that to be defined here. This is the main cavity. So here I size this for my little dragon capsule. And I have interior width, I have interior, escape first, click on that, interior length. And then that is extruded to the depth of cavity depth. So pretty straightforward right now. Actually, the whole thing is pretty straightforward. It's just, you have to plan ahead, think through what features you need and what values define those features. Extruding a cavity on both halves. And what is this? Okay, so there's a radius here, and there is also a radius, let me click through a little more, in here. I took into account the, there's a little field here where you can plug in your end mill diameter. That sort of defines what this inner radius is. It's the radius of the end mill. Actually, this is not an actual expression right now, but this should be end mill diameter divided by 2. And then I like to provide just a, not make that the perfect fit corner for your end mill, because otherwise you'll get a little bit of chatter there as the end mill makes a sharp 90-degree turn. So I like to multiply it by at least 10%, so 1.1 for that radius. And this lip stops a certain margin away from the magnet pocket plus the end mill diameter. So I just leave plenty of room there so that when you fold this lid onto this base, this doesn't run into this. So you can define that distance however you want. That's just a quick and dirty way, using some of the parameters I came up with, to separate these two features. I don't think there's much more left. There is, I actually just modeled in some magnets just so that I could render this out. And one of the things I like to do when I render is put a small fillet on everything. Because in real life you never have perfectly sharp corners unless it's freshly cut aluminum that'll slice your finger open. There's always a little bit of softness on these edges. So when you go into the render workspace, it looks a little more realistic. You don't get that super sharp fall off in light. It's just a nice subtle gradation between these surfaces. But when you're actually designing, you don't want that, so just keep that render fillet, as I call it, at the very end and just suppress it when you don't need it. But that is the model in a nutshell. I've patterned these out. Just a known gap that keeps these walls consistent. I think there's even spacing between all of these boxes. And I patterned these out like this because depending on the width of your stock, it's easier to just pattern out the same number of lids and bases. So if I have a 6-inch wide piece of stock, I can fit 3 boxes in there. And then if I want to make more of these, if I have a longer board, I can pattern both of these out in the Y direction. All right, moving on to the CAM workspace. There's a couple ways you can do this. If you have a perfectly sized piece of stock that is 5.375 inches wide and 4.5 inches long, you can create a pocketing toolpath that will just sort of dip into the areas it needs to cut and ignore the rest. So if I have stock contour selected and rest machining from stock setup, the toolpath will look a little different. If you have a table saw, you can totally just cut down pieces to the exact size you need, use a touch probe to find your origin at a corner, and have a slightly more efficient toolpath because the end mill can sort of dart in and cut what it needs to and then exit without helixing down everywhere. But for me, if I'm just cutting this out of a oversized board or piece of plywood, I won't have Fusion take those assumptions about where the stock is. It's just going to cut basically everywhere, continuously around the perimeter, and yeah. That actually came out to be like a minute faster. There's some quirks I might not have given enough outside margin for the containment of that toolpath, but you can play around with this as you see fit. If you have a different CNC, you can also change how aggressive your depth of cut is. For me, using adhesive work holding, I really didn't want to push this too hard, so maximum roughing step down of 0.08 inches, roughly 2 millimeters, was enough for me. So next toolpath on this is in a pattern. Since the roughing toolpath will just target all the models in the project. This, I'm targeting contours, and I don't want to select them 3 different times, so I'm just patterning out one set of toolpaths for one box across all 3. Here, I'm doing a trace operation on the perimeter of this lip. You could do a pocket. I find the pocket to be less efficient because what the pocket's going to do is the pocket's going to cut a little on the outside, and it's not nearly as well contained. As long as your end mill diameter is larger than the width of your lip, just do a trace operation. It's faster, it's more efficient, it'll be just as good. After the trace, I clean up the inside walls, leaving a little bit of axial stock to leave so this toolpath doesn't completely touch the floor. It's hovering just 1.5 thou above that surface. We'll clean up the inner ledge here, just the outside perimeter. Then we'll hit the faces, pocketing toolpath, clean up the inner walls here, do a pocketing toolpath to clean up the floor, then a full depth of cut spring pass, and also just to erase any waterline marks. These are the cleanup toolpaths for the pocket, the magnet pocket. This is a drilling operation. So what I like to do is I will, let me just simulate the whole thing, go to this toolpath, show stock, hide the toolpaths, and let's hide the models. And let's go standard, so this doesn't look like garbage. When you're gluing in magnets, if there's no place for excess CA glue to go, it'll squeeze out around the magnet, go over the top of the magnet, and basically, if it seeps over your wooden interface surfaces, finish isn't going to be able to penetrate into the wood fibers. If it gets on the magnet, it doesn't look clean. So one of the things I've started doing now is to just provide a little bit of relief for extra CA glue to just seep into. An 1/8 inch end mill, that little divot is perhaps a little bit much. Where's that drilling toolpath? But if you use maybe like a 1/16 inch end mill and just put a couple holes in there, that'll just give extra CA glue a place to run. So that's just a little neat thing that I like to put in there. I'm using an 1/8 inch end mill just because I don't have an automatic tool changer and I'm lazy. So that has to happen while I still have this tool loaded. Next thing up is a finishing pass on the outside. So one thing to note with my initial roughing toolpath is that it doesn't go all the way to the bottom. I like to keep the stock contiguous until the very end so that like each box can help secure its neighbors since I'm using adhesive work holding. And also, if I can avoid cutting through the stock and potentially nicking that double-sided tape, I can keep the cutter clean from any adhesives and not be gummed up and smear that adhesive on the walls so that chips stick to it. So if I can avoid cutting through until the very end, I like to do that. So here I am finishing the walls, then cutting through everything, and then doing a spring pass to clean that up. So if you look here, there's a couple thou difference between these two toolpaths, really subtle, but that just means that finishing toolpath will be removing a little bit of material and you get the smoothest possible finish. That finishing toolpath is going to be, at least in here, going to be a little slower than the contour toolpath. Smaller chip load, slightly finer finish on the walls, But you can play around with that depending on what diameter cutter you're using, how many flutes you have. The more flutes, the faster you can finish. So small things like that you can play around with. But for me, I'm just using an 1/8 inch down cutting end mill, and that's it. So hope this gave you an idea of how you can use basic parameters to come up with more complex geometry that you can basically infinitely scale. Like if I want to change my outer radius, that's easy enough. If I want to change the overall width of my box to make these super chunky, also easy to do. So yeah, parameters make it really easy to just modify aspects of your model without having to dig through each of the sketches or features of your project. So give that a shot. Hopefully it works out. If you make your own box, tag me in an Instagram post. I'd love to see what you're doing. Good luck, have fun, and thanks for tuning in.